Thank you for joining us for today's Würth Elektronik and Texas Instruments online power seminar, Getting Started with Power over Ethernet. Today's presenters are Brett Coulteau, Product Marketing Engineer with Texas Instruments, and Apurva Engel, Product Definition Engineer with Würth Elektronik. Both will be answering questions at the end of today's presentation. As a reminder, today's power seminar is being recorded and you will automatically receive the on-demand video and PDF of the slides when they become available. Don't forget to register for the next online power seminar, USB Type-C and USB Power Delivery Made Easy on June 9th. Register online at www.we-online.com/events. And now to begin today's presentation is Brett Coulteau.
So thank you everybody for attending our power seminar today. I want to thank Wurth Electronics for partnering with us and for putting this together. My name is Brett Coulteau. I'm a product marketing engineer at Texas Instruments. And today I'll be educating you guys on power over Ethernet as a technology. So on a high level, today what I plan on talking about is, power over Ethernet. I want to introduce, what is PoE and when does it make sense to use PoE as a technology, as well as, touching on kind of the value prop and why most folks use PoE, as well as touching on, our traditional, PoE applications, as well as some emerging applications that we're starting to see adopt PoE at an accelerating rate. In addition, I want to highlight some reference designs that we recently put together that I think can definitely help folks who are new to PoE to get started with PoE as a technology and to start learning more about how PoE can be used for them and their applications. So let's jump into it. So first off, what is PoE, right? So on a high level, PoE is providing a DC power, 44 to 57 volts, although most customers do use 48 volts typically, over the same Cat5e cable that carries Ethernet data. So over here you can see we have an RJ45 receptacle, a Cat5e cable that plugs into the receptacle, and then inside of the cable, if you were to cut it, you'd see 4 twisted pairs of wire that are used to send power and data over the same cable. In terms of some high-level terminology, you'll hear me reference PSE and PD several times throughout this presentation, so I think it's important to define them. On the sourcing side of the cable are typically Ethernet switches that provide power over Ethernet. And inside of these end equipment are our PSE or power sourcing equipment controllers. So at TI, we design PSE ICs that basically negotiate with the load. There's a handshake that happens in order to determine how much power needs to be sent to the load, and then that power is allocated and sent across the cable. So you'll hear me refer to the sourcing side as the PSE side of the cable. On the load side is what we refer to as the PD, or the power device side of the cable. And again, at TI, we design and manufacture power device controllers that negotiate with the PSE how much power needs to be sent. And traditional power device and equipment are IP phones, wireless access points, and security cameras. And these are the traditional kind of PoE bread and butter end equipment here. You're probably wondering how much power can you send through PoE. And PoE has evolved over time through various different standards. So in 2003, the IEEE committee got together and defined what we call the 802.3 AF standard. And this enabled the PSE to send up to 15.4 watts and for the PD to receive up to 13 watts after 100 meters of Cat5e cable. So there is some power loss in the cable, but you are sending it for 100 meters. So that was the AF standard that came out in 2003. In 2009, the IEEE 802.3 AT standard was introduced, which enabled us to send up to 30 watts from the PSE and to receive 25.5 watts on the PD. And then just last year, in 2019, the BT standard came out, which tripled the amount of power that we can send. So PSE can now send 90 watts of power, and a PD can receive up to 71 watts of power. again, after 100 meters of Cat5e cable. So the need for more power has evolved over time, and the IEEE standard, or the IEEE committee has responded by redefining the 802.3 standard to enable higher power to be sent. So one question that I get often is, why would I want to use PoE, and when does it make sense to really use PoE? And one of the main reasons that I see folks use PoE is really when they want to send power and data, over the same cable up to 100 meters away from like an AC mains outlet or a source, right? And this also comes into kind of convenience of installation and use. So if you imagine having a security camera, you want to install this in the corner of a room, chances are you're not going to have an AC mains or an AC outlet, in the corner of that room. So this is where PoE would come into play, where you can conveniently install that camera wherever you'd like to install it, up to 100 meters away from a source. And one of the main benefits of this as well is that there's no electricians required for the install. So anybody can go ahead and install those end equipment. Another reason why folks choose PoE is because of, it's an IEEE 802.3 standards-based. In addition to it being a standards-based technology, at TI, we're really committed to product longevity, for our customers, and we have strategies and policies in place really to uphold that commitment. And so, from a designer perspective, part obsolescence is very uncommon from TI and within the PoE world. So that's another kind of main reason why folks choose PoE. In addition, you can send power up to 71 watts at the load, so it's really scalable to meet various power demands of your system. In addition, I see a lot of folks starting to use PoE more and more for power redundancy. So in security cameras or access points, I'll see folks use multiple PoE inputs. For a security camera, you never want the power to go down. You always want to be surveying. And so it's important to have multiple power supplies in case one PoE port were to go down, you could have another PoE port as backup. And last but not least, a lot of folks choose PoE. And one of the main value props of PoE is that it's standards-based, and so you can really have confidence of interoperability between certified products. So the Ethernet Alliance has put together a certification program. And at TI, we have several of our reference designs that we have put through this test suite to basically get EA certified logos on our end equipment and are on our evaluation modules or reference designs. And so what this translates to from a customer perspective is, if you are able to get an EA certified logo on your end equipment, from a marketing perspective, this highlights to the industry that your end equipment is going to be interoperable with other end equipment that meet this IEEE standard compliance. So from an installer perspective, it's very easy to go in and to install end equipment that have these logos on them. So if you can imagine the logo on the left, this would be a logo that would go on an Ethernet switch. This says I'm a class 4 PSE. The arrows going out, which means I'm a source of power, and this 4 here represents the power level of the PSE. So class 4 power level represents 30 watts. So this says I can send 30 watts per port. This logo over here says I'm a class 1 PD. I want to receive power. As long as this power level is less than over here, you can go ahead and plug in these end equipment, and they're guaranteed to interoperate, which is one of the beautiful things of having the EA certified logo. So I wanted to highlight some of the primary applications that use PoE today, and then highlight some of the kind of emerging applications that I'm starting to see about PoE. So as I touched on earlier, some of the primary applications that use PoE are enterprise switches, as well as PoE pass-through and injectors. So this pass-through and injector, these are really adding power to existing solutions that are sending data over a Cat5e cable today. So these are used to, inject power over that same cable. On the load side, traditionally it's IP phones, cameras, access points, and small cells. However, I'm starting to see PoE being adopted by, more and more end equipment every day. Some examples you can see here: electronic smart locks, occupancy detection, video doorbells, HMI panels. I'm also starting to see PoE adopted in, medical and nurse call stations, baby warmers, just various different, applications. So just wanted to highlight that, if you are using a Cat5e cable for data today, why not add, why not use that same cable for power and data? Another question I get a lot is, why TI PoE, right? And this is definitely a very fair question. One of the reasons why I find that a lot of customers stick with TI or decide to come to TI, when they're, new to PoE, is just because we are, we have a complete portfolio end to end on the PSE and PD side of IEEE 802.3 compliant solutions. And we really pride ourselves on the number of reference designs that we have available for our customers to kind of help them to get started and to accelerate their design. So when you come to TI.com, you can take a look at our hundreds of reference designs that can help you to go ahead and get started. We have EA certified reference designs that can be copied and pasted to put you in a good standing to get the logo on your end equipment. And we really pride ourselves on having standards-based solutions that are interoperable. So those are some of the main reasons why customers come to TI to go ahead and get started with their PoE designs. All right, so let's highlight some of our reference designs to go ahead and get you guys started with learning about PoE as a technology and kind of plugging and playing. So this is a reference design that we just put together. This is basically an Ethernet switch. So we have a 24-port PSE reference design. So this design uses our TPS 238A1, which is our BT PSE. It can send up to 90 watts per port for BT compliant applications and up to 120 watts per port for non-standard applications. We partnered with our MSP 430 team at TI, and we put together kind of what we're referring to as our firm PSE ecosystem, which is basically a really easy to use GUI along with our hardware here that enables customers to basically reduce their software resources by enabling port power management methodology through the use of our GUI. So taking a step back, why would somebody want to use port power management in an Ethernet switch system? If you imagine this switch here, we have 24 ports. We could send 90 watts per port. I think that's, a couple kilowatts of power, right? And in reality, most customers are not going to use a 2 kilowatt power supply, in their system. They may use a 500 watt power supply or a 1 kilowatt power supply, and they'll use some sort of smarts, some sort of port power management in order to allocate power appropriately to different ports based upon the port priority and what they're trying to do in the ecosystem. And so that's what we've gone ahead and created, is basically an easy to use GUI that enables you to kind of reduce that power supply so that you can implement port power management in your PSE system. So for folks who are interested in designing, Ethernet switches, we've basically taken a lot of the heavy lifting out from a hardware and a software perspective. In addition, we also have this same reference design for the TPS 23882. This is just our lower power level IEEE 802.3 AT PSE that can send up to 30 watts per port for type 3 compliant applications and up to 60 watts per port for non-standard applications. The only difference here is going to be the daughter card. So it's a different daughter card that you order to evaluate the lower power level 24 port design. So I kind of touched on like firm PSE and what this means to you. So on a high level, once you get this evaluation circuitry in your hand, you'll go ahead and download our firm PSE GUI. And just by using our drop-down menus and, it's really easy to use. You basically input into the GUI and output is going to come, a production ready firmware code image. that you can then flash to your system and use in a production level environment for port power management. So again, just doing as much as we can to take off the heavy lifting, specifically on the software side of things. So switching it up in terms of the load side of the cable, one of the reference designs that I wanted to highlight is our TIDA 010083. This is our really small solution size type 1 PD 13 watt 5 volt reference design. It's catered towards machine vision and vision sensors, but also I've seen a lot of customers use this in just applications that require very small solution size. So this reference design uses our TPS 23758. It uses it in a primary side regulated topology, which eliminates the optocoupler and kind of all that feedback network, really enabling a small solution size. In addition, the TPS 23758 has a feature called spread spectrum frequency dithering, or SSFD, which enables the dithering of the switching frequency to reduce EMIs or enable easy Class B EMI compliance. So this is a really great reference design for 5 volt systems, up to 92% efficient and better than plus or minus 2% accuracy in a really small form factor. So this is a design that I recommend for anybody who's designing applications requiring small solution size and kind of the 13 watt space. All right. So I wanted to wrap up by giving you guys some resources so that you can go ahead and kind of get started with learning more about PoE. I recently spent a bunch of time with my team creating a PoE training portal that basically highlights like what is PoE, what does the handshake look like, basically educating folks on some of the power basics and some of the operation considerations. So these are really short videos, about 5 minutes or less, just to try to educate folks on PoE as a technology. So if you're interested in learning more about some kind of PoE basics, I recommend you go to ti.com/PoE, and you can check out our PoE training series and walk through our videos here. In addition, you could order, any of the reference designs that I talked about today. Otherwise, if you're just looking for some general, evaluation hardware, maybe some lower cost hardware just to kind of learn about, the technology and just start plugging and playing. Here's some kind of general reference designs that I would recommend taking a look at. And that's all I had on my side. If you have any questions, feel free to go ahead and type them up and ask them while Apurva's presenting. Feel free to send those questions in and we'll take a look and I'll be prepared to comment at the end. Thank you all.
Here we go. Hello, everyone. My name is Apurva, and I'm a product definition engineer at Wurth Electronics. First of all, I would like to thank Brett for giving such a good overview of PoE as a technology. And as we saw that land transformer is a critical part of PoE design, and Wurth Electronics being one of the leading manufacturers of passive magnetics, I would like to take this opportunity to talk about land transformers in little more detail. Under this topic, we'll be covering the following points today, starting with purpose of land transformer in PoE. Then we'll go through different types of land transformers, such as discrete and integrated. Moving on to the parameters to look out for when we are selecting this transformer. After this, we'll briefly go through a couple of extensions and new topics in the LAN technology, such as HPLE, which stands for High Performance Low EMI LAN, and SPE, which is Single Pair Ethernet. And lastly, we'll conclude by discussing few circuit considerations and measurement techniques. And I'll also demonstrate a very easy online selection tool that is available on our website. Let's get started with the purpose that a LAN transformer has to serve in a PoE type of application. Firstly, it is to provide electrical isolation for safety reasons. Now, when an Ethernet cable is laid, it's often parallel to the high voltage cable as well as many other signal cables. Now, this could potentially cause very harmful and disruptive disturbances. Therefore, we need protection against the high voltages, and LAN transformer helps us to achieve exactly that. Typically, the standard voltage level goes up to 1.5 kilovolts. But for certain medical and industrial applications, the voltage can go up to 4 kilovolts or in some cases even as high as 6 kilovolts. Now, a land transformer is expected to reduce the electric shock to the end user by providing isolation between the primary and secondary side. Next reason to use a land transformer is to help us with impedance matching. Now, this ensures that the output of the transformer has the same impedance as that of the connecting cable in order to maximize the bandwidth. And lastly, a land transformer provides EMI separation. Now, most land transformers come with an inbuilt common mode choke, and this choke helps us to reduce the undesired and unwanted noise. Okay, now let's take a look at the position of land transformer in a typical circuit. Now, normally we start with the IC. It could be something from TI, which Brett mentioned in the previous part of the presentation. And then we have the land transformer, which comes in between the IC and the cable. Now, under the scenario, the IC here is helping us with the digital signal, which is filled with like a lot of information and data. Then land transformer is actually taking all that signal and passing it on to a connector. And in between, the land transformer is helping us to isolate that transfer. And this kind of a separation is also referred to as galvanic separation, which is to make sure that the board is not directly in contact with the end cable. Now, when the land transformer takes the signal from IC, it gives it to RJ45 connector. And this type of transfer, it is sometimes referred to as magnetic coupling. And this RJ45 is then eventually in contact with the end cable. Now, this is how the whole picture of the setup would look like from the power source device, PSE, to the end device, which is the PD, powered device. Now, we have one pair of transformer and connector on the PSE side, and through the cable, it is connected to another pair of transformer and connector on the PD side. Now, in order to get power to the device, we first need to generate this power at the sending side of communication. Now, as we need certain voltage and current to be supplied to our receiver, the sending device has to generate this power and transfer it to the connector. Now, on the PSE side, the power is getting transferred to land transformer, which gets passed to connector. And inside this connector, the electrical power gets mixed with the data signal, and together it moves to the cable. At the receiver side, we now need to separate the data signal and power. Data signal very easily moves to the land transformer, whereas power gets separated and is transferred to the power supply section of this device. A small point to note here is that the flow of power or the transfer of data is always one way, and it only goes through PSE to cable and to PD. Now, in general, there are two types of land transformers that are used in PoE kind of applications, discrete and integrated. We'll start by talking about discrete first. As you can see on the left side of the screen here, a LAN is basically a small black box with multiple pins or legs on it. Taking a closer look at the schematic shows that it is made up of two essential components. One is the common mode choke, and second is matching or isolation transformer. One pair of transformer and choke is present on the transmitting end and another on the receiving end. As we saw in the previous slide, the transformer here is providing us with galvanic separation, and common mode choke is helping us to reduce EMI. Now, the number of pairs of transformer and choke that we need entirely depends on the speed that we are trying to achieve. For example, the left circuit here is for 100 megabits. And in this case, we need two pairs of transformer and choke. Whereas on the right side, the circuit is a little more complicated because we want to achieve 1 gigabit. And therefore, we'll need 4 pairs of transformers and choke. Now, this slide will show you the structural differences between different values. For example, let's say we are considering 1000 base T, which will have little more pairs and it will take up little more space compared to something like 100 base T, which only has 2 pairs of transformer and choke. Increasing the speed furthermore, let's say for 10G base T, the number of pairs are going to increase, the package of the land transformer will be bigger, and it will take up more space on the board. Moving on to next type of LAN magnetics, the integrated LAN. Now the configuration of integrated LAN is, I would say, 80% similar to the discrete one, with a common mode choke and isolation transformer. But in addition to these two components, integrated LAN also has something called a box with termination. Now this termination is a resistor network containing 75 ohm resistors on each twisted pair, and this connection goes to ground through a 1000 picofarad cap. Now the result of this additional setup is just to provide us with extra EMI separation. Further elements that we can add to an integrated LAN could include something like a triple winded common mode choke and two common mode choke on one core, which is also referred to as an auto transformer. The reason that these elements are part of some circuits and not present in some other, it entirely depends on what kind of inner wiring you have from the plug to the customer's application. Now, when we have too many lines and too many plug points and there is like a lot of crossing, there is some loss of performance. Now, to compensate for this loss, these type of additional elements are needed. Within RJ45 as well, we have different type of structural differences based on what is the mounting type or if they have built-in LEDs or not. I mean, in this slide, we'll go through a few of those examples. Let's say this is an RJ45 with a through-hole kind of construction, which has small legs at the bottom of it to help us with soldering on the board, versus something like an SMD, which is much more flatter and we just need to like solder and paste it on the board through reflow or some other kind of technique. Then another type is tab up, which could have few LEDs inbuilt in it. Tab down with no LEDs, entirely depending on what application you are trying to put it in and how much space the board is allowing. Next would be a simple RJ45 with no EMI fingers. And lastly, something which has like a very tiny extension to the board, to the LAN, which is called EMI fingers. And benefit of having EMI fingers, or in some cases, it is also referred to as tabs, is to ensure a good high frequency short circuit between this connector and the panel where it is getting placed. At high frequencies, it's just not enough to have just one ground connection. The more connections we have, the better performance we get. And that is where EMI fingers, a very small addition to the LAN transformer, can help achieve that. Now, these are a few more examples of how the final product of RJ45 looks like. Different parts, they have different external structure based on the power level that they are achieving. Like the ones on the left side, which are relatively smaller and they don't have any inbuilt LEDs, and they are specifically for 30 watts or 60 watts of power, versus something like this, which is very huge because it has USB ports inbuilt in it, it has LEDs inbuilt in it. So depending on what type of selection you are making, how many integrated components it has, the external structure of each and every RJ45 is going to change. Now, talking a little bit about the electrical specs of a LAN transformer. The equivalent circuit is fairly simple with a few basic passive components combined together. Like here we can see in the circuit, the leakage inductance, winding resistance, and distributed cap, they are present on both primary and secondary side of the circuit, whereas magnetizing inductance and core loss resistance are present on the primary side. And lastly, there is a winding capacitance, which is connecting the two primary and the secondary winding for us. Now, based on this circuit, we can define the parameters that are important when we are selecting a LAN transformer. Now, here you can see a sample data sheet with all the parameters listed and all the values given, for example. Now, we will go through each and every parameter and see what it means exactly. Starting with auto MDIX. Auto MDIX is basically the property of switching in between channels. Now, normally the twisted pair ports must be connected so that the transmitting pair on one end is connected to the receiving pair on the other, and vice versa. Now, switching in between these two different channels, or how many channels we need, entirely depends on the second property, which is speed. Like, let's say for 1000 megabits per second, we might just require 2 channels. But if we increase the speed to 10 gigabits per second, then we might require 4 or even 6 channels in some cases. And Auto MDX will define the capability of how we switch in between those channels. Next parameter to consider is open circuit inductance. Now, this is the inductance which is measured when the transformer has no load connected to it. Defined by IEEE standards, it must be a minimum of 350 microhenry for something like 1000 base T or 10G base T type of applications. Next parameter to look for is the insertion loss. Now, when we put a transformer in between the source and the load, some power gets lost through the transformer winding and its core. Insertion loss helps us to calculate how much exact signal is actually passing through the transformer and going to the load. So it will give us the value of what is the final measured signal that we get on the load. Whereas return loss is slightly opposite of insertion. Now this will compare the measured impedance and the standard impedance, and based on the difference, it will give us the value of the signal which is getting reflected back to the source. So insertion loss we calculated at the end of the load, and return loss we see whatever signal is coming back to the source. Next property is differential to common mode rejection ratio, DCMR. This is a measure of how much of a differential signal can we convert into common mode signal. This we do because it is much easier to get rid of common mode signal simply by using a common mode choke. That is why we need to convert the differential signal into common mode first. And following that, we have a property named as common mode rejection ratio, which will help us to reduce the ultimate common mode noise or common mode signal that we have simply by using a common mode choke. Lastly, the property to look for is crosstalk, which is the amount of energy that is coupled on a signal path from another nearby signal. For example, if we have two signal paths which are very, very close to each other, it's very likely that we'll see interferences of signal in between these two paths, and crosstalk simply gives us the measure of that. A couple of extensions to the topic of LAN these days, starting with HPLE, which stands for High Performance Low EMI. Now, we know that we require to have a common mode choke in a LAN transformer for noise reduction, but the initial standards only cover frequencies up to 100 megahertz. However, these days we see applications which go in gigabits range, and they are expected to have very, very low noise limits. And in this case, now we have started to see a little bit of issues in performance when it comes to higher frequencies. A simple solution for these kinds of problems is to add two common mode chokes on the physical logic unit, which will increase the common mode rejection ratio. Now, this increases the attenuation in the frequency range from 80 megahertz going up to as high as 500 megahertz. So, like with comparison to initial standards, we are jumping literally 5 times just by adding 2 more common mode chokes. So this is the circuit where we can see the difference between standard LAN versus the ones which have HPLE. Here we just have a regular pair of transformer and choke, whereas on the right side we have 2 additional common mode chokes who are helping us to increase the common mode impedance and eventually helping to reduce noise up until 500 megahertz. Now, a new market in the world of Ethernet right now is for single pair Ethernet. In certain applications like CC-Link or Modbus, the length of the Ethernet is just not long enough. We have a capability only till 100 meters. Now, traditionally, we have seen that the Ethernet connections, they have either 2 or 4 pairs. SPE will help us reduce them down to just one single pair. And this will help ultimately in reducing the space and enables us to have a comprehensive and standardized communication between many separate devices. It also lengthens the distance between these components to 1,000 meters. And that is why this looks like it will be a key technology when it comes to applications like 4.0 and IoT, where the end devices are separated by longer distances. And finally, this slide shows a little bit of how the measurements are done and what are the key points when we look for when we are selecting a LAN. For example, this is giving us a comparison between when we put current into one channel versus what happens when we put current into two. Definitely the power that we get at the end will increase when we are putting the current through two channels. But a key point to note here is that, let's say we put 0.6 amps, and based on that, we are getting out more power. And the heating of the transformer coil is at 8.7 degrees C. Versus when we increase the current to 1.2 amps, the heating now goes as high as 35 degrees C for the same test duration. So even though while selecting a transformer, you might think that, okay, it is able to take the current, definitely it will. But at the same time, we need to make sure that we are not heating up the transformer beyond its limit. Now, taking into account all these parameters and measurement setup, we have developed a very easy online tool that is available on our website called RedExpert. And it can help you with better selection, with better understanding of the product. So now you can just like follow the link, which will be available later in the presentation, or you can simply type in RedExpert on Google and it will direct you to the homepage of RedExpert. So now we'll just like have a quick demonstration of the tool. And that will be the last section of this presentation. So like I said, you can either just go and type in RedExpert and it will direct you to the home page of this tool. Okay, so this is the home screen, and our search engine is basically divided widely into products and applications. So if you already know what is the end application that you are targeting, you can just select few basic applications here, and this will help you guide in better selecting of the passive components. But for today's demonstration, we'll directly go to products, as we know our focus products for the day. And let's say we are trying to select RJ45 LAN transformer. So now under RJ45 LAN transformer, RedExpert will show you all the RJ45s that we have in our product catalog, which are available on the website. If you can see on the top right side here, we have 154 selections, which is way too high, and we need help in narrowing down to the best possible part that we need. So there are like several different tabs which can help us narrow down the selection to the exact one part. For example, let's say we know the speed that we want to operate at. Let's say it's 1000 Mbps. So now it will reduce the selection from 154 to 103. Then we can also select it based on the application that we are targeting. For example, let's say we want it to run under PoE. Now we just have 22 items left to compare. Further, you can also sort down the selection based on the mounting type, whether you need through hole or SMT, whether if it's tap down or tap up or vertical, depending on how are you planning to insert it on the board, as well as what color of LEDs do you need. So basically, you can narrow it down on several factors. After we have like a certain amount of number which we just want to compare with, we can just select any number of parts and it will get added to the tab here. So there is no limit of numbers that you can add. You can add endless numbers and compare it based on schematic, mechanical dimensions, or the solder pad details, and just keep switching in between and you'll see data for each and every part. Now, if you need even more technical details, the spec sheet is already attached here. You can just click on the PDF and it will take you to the data sheet, which is more detailed, and you can look through the schematic and the electrical values. And even after that, if you need any kind of technical assistance or if you need samples, for samples, it is pretty easy. You just add it to the cart. But if you have any more technical questions, you can just go here. If you know the email address from Wurth, you can just send us the question, send us the query, or just ask it to any of the representatives of Wurth who are also available on the social media platforms like LinkedIn and Twitter. And similar thing is for discrete signal transformers. We have a separate tab for that. But it is pretty much the same. The selection tabs are pretty much the same based on speed or based on the application, whether you have HPLE extension features or not. So you can again simply play with the tool and see all these details and help share it with us or share it with the team and just look through it. I think this is it from my end from the presentation point, and I think now Britt and I would take the questions that you have already posted. Yeah, that's it. Thank you so much.